All right, so for our last example, we're going to take a look at an even more complicated area question. This is about as complicated as they can get, and you'll see why. So again, we're working with two functions on the same graph, and they want to find the area of the common interior, which is just a fancy way of saying the area where they're overlapping. So let's go ahead and jump straight into graphing. All right, so we've got our 3 cosine theta, which is going to be a circle, and it's going to be symmetric around the x-axis, and it's a positive 3, so it'll be on the right with a radius of 3. I know it starts out at 3, it goes into 0, and then it goes back out. All right, and then I also have the graph of 1 plus cosine theta. So in this case, the amplitude and the shift and the amplitude are the same, so this should make a cardioid. Again, it's going to be symmetric to the x-axis. So I might have to kind of think this one through a little bit, though. So cosine of 0 is going to be 1, and 1 plus 1 is 2. So this one will start here at 2. And then cosine of pi over 2 would be 0, so that's just going to be a 1 by the time it gets over here. That might need to be a little higher. There. So we're going doop. And then it's going to be cosine of pi, which is negative 1, so that's actually where it's going to come back and hit the pole. That's 0. And then we know it's symmetric, so you can keep plugging in or you can take it from there, but it should make our cardioid. Okay, I redrew mine to kind of make the inside bigger so I could notate some stuff that's coming up, but you get the gist. Okay, so we want to figure out this common interior area, right? So if we were to shade in the green and shade in all the purple, where are they overlapping? In this region here. So the first thing I feel like I'm going to have to take a look at is figuring out maybe what's the location of this, like where is this occurring? But I see some bigger issues coming up for me because of the fact that this area who's furthest away and who's closest isn't consistent once we get over here, which is why I was trying to draw it a little clearer. So let me explain what I mean. So you can see that we're going to use symmetry here and find this top half and then multiply it by 2 to get the entire area. And obviously the first angle we would be using would just simply be 0. But if I were to just go to the intersection point here, which I'm doing my best to illustrate what that might look like, I'm going to kind of lose a little tiny sliver here, which if my circle were more accurate, it might be more obvious exactly what it is I'm losing. But there's some area to the left of this that would get chopped off, right? So we would be really good about getting all of this area, but we would kind of lose this here. So that's what makes this one a little more complicated, is our theta that we're using isn't alone all that we're going to have to take into account. All right, so again, the first thing I need to do is find that point where they're meeting. So we're going to take the two functions and set them equal to each other. Oh, this guy went away at some point when I was fixing my drawing. All right, so 3 cosine theta, where is it going to be intersecting with 1 plus cosine theta? So again, we would, in this case, subtract cosine. So we'd get 2 cosine theta equals 1. So we'll be looking for when cosine of theta equals 1/2, and that is going to first occur at pi over 3. So that's what I'm going to use as this particular angle. So the main difference with this one is we're not subtracting areas, right? So we're not finding the area between them. We're finding the area where they're both going to be shaded in. What's different is the way that we find the first part of this area is to find that, well, let me draw it from the pole, to find that inside area of the green graph in this case, or the cardioid. That covers the area up to that pi over 3. So basically my first area, again I'm going to use the 2 for symmetry, 1/2, and this guy starts at 0 and goes to the pi over 3 of, who is that, 1 plus cosine theta squared d theta. And now I'm going to add to it this little extra sliver that, again, if my circle were just a little bit more accurate, you'd be able to see better, of this purple graph from pi over 3, right? That's where it's starting, and it's the area from pi over 3 to pi over 2 of that purple graph. So again, had this been a more simple problem, we could have just gone from 0 to pi over 2, but because where that inside area is occurring switches at this intersection point, we have to break it up into 2 pieces. Okay, now the other thing that makes this one more of a pain is because these bounds are different, I can't just write one integral. I can still definitely cancel out the 2 and the 1/2, but I'm not going to be able to simplify it much past that because the bounds are different. So we're still going to have 2 separate things to type in. The first one and then the second one. That little tiny, tiny, hard to draw piece. All right. You could still type it in basically as your R1 and your R2 just to save yourself from having so much on your screen at once. But whenever you do that, I'm hoping you get an estimated answer of 3.927.